Risers, hello there. Welcome to your Chapter 4, Lesson 2 notes, and we are going to multiply radicals. So actually, we're going to do this twice before we have our quiz. I'm going to keep it simple for this one. After we've done Lesson 3, the adding and subtracting, then I'm going to go into a little bit more complicated multiplying radicals. But the basics of multiplying radicals really is basically the same as simplifying. Okay, so what you do is if you have two radicals multiplied together, what you do is you will just simplify out the pieces after you've multiplied the outside numbers together and the inside numbers together. So whatever that big combined radical is, then you just simplify it. That's truly what multiplying radicals looks like. And it's not that bad. So again, just real quick, what we needed to know from yesterday, how to simplify. Of course, these are your notes. So what I'll do during the video so that you don't have to take time, I don't have to take time reading, you can do that, is I'll just do the examples. So in exercise 1, we have radical 48x cubed. We're taking the square root of it. So we think, well, what's the biggest square? What's the biggest perfect square that divides evenly into 48? That's 16. So I make my perfect square radical, and here's my leftover radical. And 48 divided by 16 is 3. And then I do that same thing for the x's. Really, with the x's, just subtract 1 from the exponent. So if it's an odd exponent, subtract 1. What do you get? X squared, that's your perfect square. That 1 is the leftover. So take the square root of 16, take the square root of x squared. Square root of 16 is 4. Square root of x squared is x. That's on the outside. The leftover, radical 3x. So that's what we did with simplifying yesterday. Continue again. What if you have a number out front already? Well, you still divide into perfect square and leftover, and whatever the perfect square when you take its square root is, it multiplies by this coefficient here. So -2 times perfect square stuff and leftover stuff. Let's see what we got here. Ooh, 16 is a perfect square. Cool. I don't have a leftover number. X squared is a perfect square. Cool. I don't have a leftover number, but y to the 5th is not a perfect square. What's 5 minus 1 for the exponent? Y to the 4th is a perfect square. Y is not. So that is the leftover. That's it. Take the square root of the perfect square. Square root of 16 is 4. Square root of x squared is x. Square root of y to the 4th is y squared. And you multiply all that by -2. So to get your final answer, multiply all that stuff by -2, and you get -8xy squared radical y. That's your final answer. That's what we talked about yesterday and previously. Now, it's just one big simplifying problem for multiplying square roots. So just take a peek at this guy right here. Okay, so the multiplication property of square roots. If two radicals are being multiplied together, you can put them together under one radical for one big answer under your radical, one big radicand, right? That makes perfect sense. Think about that. That makes perfect sense. That's the opposite of what we've been doing with simplifying. So it makes sense that it goes the opposite direction. Okay, and then once you've done that, you can see if now those numbers that are one big radicand have any perfect square factors to be brought out. For example, radical 2x times radical 30x. Stopped midway. Those numbers multiplied together, each number separately does not have a perfect square factor. But once they're multiplied together, all of a sudden, you get radical 60x squared. And now there are perfect squares that can come out of that. So that's what we do. We're looking at this radicand now in a different way. And instead of these things that can't have perfect squares come out, now we've made one bigger radicand that can have perfect squares come out. So that's kind of the point of when we're multiplying these radicals together, is we're trying to get those perfect squares to come out, less things stuck under the radical. Okay, let's do it. And again, I'm keeping it simple for now. Once we've learned to add and subtract radicals, then we get a little bit higher level in the multiplying radicals. There is more to learn for multiplying radicals, but I've divided it into 2 lessons. So here, let's multiply these together. Radical 2 times radical 8. Well, 2 times 8 is 16, and that is what's under the radicand. See, now I've got perfect squares that I can take out. In fact, 16 is a perfect square. What's the square root of 16? 4. That you couldn't do before, right? That wasn't looking that way before. Now, this is what you can do to get that fully out and no more radical left. Same thing is going to happen here, actually. Radical 3 times radical 12. They're both under the radical, so 3 times 12 under the radical gets 36. Ha! 36 is a perfect square. What's the square root of 36? 6. Done. So this multiplying radicals helped me because I'm getting these perfect squares out of the radicals. Okay. These other ones, they'll be leftovers. So now let's multiply together, right? 5 times 20. Okay, maybe not on this one. 5 times 20 is 100. And x to the 4th times x squared. Add the exponents on a like base. X to the 6th. All right, this is a perfect square. What's the square root of 100? 10. What's the square root of x to the 6th? X cubed. There you have it. All right, maybe now. When you've got numbers on the outside of the radicals, those multiply together and stay on the outside. So 4 times 3 is 12 on the outside. Radical 15x to the 4th times radical 2x squared. Now, that's under the radical. So 15 times 2 is 30. X to the 4th times x squared is x to the 6th. Now, if there are any perfect squares under here, you bring them out. So 30, not evenly divisible by any perfect squares. Can you believe it? But x to the 6th is a perfect square. So we take its square root, we bring it out. And if you'd like me to do this, I will. So here's your coefficient. Here's your perfect square. Here's your leftover. Okay? And now what is the square root of x to the 6th? That's x cubed. And you multiply that by the coefficient we already had, which was 12. So 12x cubed. And then radical 30 is left over. I know 30 seems like such a big number to be leaving under a radical, but trust me, if it's not divisible by a perfect square, it can't come out of the radical. Nothing smaller can come out. And so when that's the case, like we end up with some really big numbers that will never be smaller under the radical because they're just not divisible by perfect squares. So that's correct. That's how it is. All right, number 5. There is a number in front of radical 8, but it's just a 1. And we know multiplying by 1, it stays itself. So 7 times 1 is 7 in the front of my radicals. And now we've got 12 times 8. 12 times 8, right? You know what that is? Maybe not. 96. No variables involved here. Now, I need to know the biggest perfect square that divides evenly into 96. And there are a couple that divide evenly into 96. But again, I just want to show you, if you don't know, how we do this, right? So 96. Let's divide it by 4 first to see what we get. 24. Okay. There's a bigger perfect square that can come out of this. So let's try again. 96 divided by 9. Well, it's actually not divisible by 9, but that's all right. Now, 96 divided by next perfect square, 16. There it is. Because notice 6, there's no other perfect square that can come out of 6. So this gets divided into perfect square, which is 16, and leftover, which is 6. Take the square root of 16, you get 4. Multiply the coefficient, and now the square root that's come out together, we get 28 radical 6. Hold on one sec, guys. I'll be right back. Oops, there it is. Sorry, guys. Real quick at my door. Right. All right, where were we? We had just finished that one. Cool. So we get 28 radical 6 is our final answer here. Okay, now over here. So I multiply outside numbers together. So let's see here. I'm going to do it down here a little bit because I don't want to get involved over there. So outside numbers, I get a negative 12. Okay. Then here, radical 3x times radical 6x squared. Okay, so 3 times 6 is 18. X times x squared is x cubed. Ah, yes, there's perfect squares that can come out of that. So let's bring those perfect squares out. Bring my coefficient over the perfect squares. Let's see, 9, and the leftover is 2. So that's the leftover. 18 divided by 9 is 2. X cubed, okay, so 3 minus 1 is 2. So x squared is the perfect square, and 1x is left over. Now take the square root of the perfect square. So 3x. There you go. Now multiply those guys together, okay? So you can get negative 12 times 3 is negative 36x. Bring the leftover down. 2x is that answer for the leftover. So negative 36x radical 2x is that final answer. So guys, it's quick homework. All right, just practicing this multiply part. It does get a little more difficult after we know how to add and subtract. So make sure you have this part down. Definitely do that practice. Ask me if you need anything. Use the graphing calculator to test perfect squares that divide evenly into those radicands. Okay, get the biggest one, and then you don't have to worry about subsequent leftovers. Okay? And that's it, guys. So I'll be seeing you for lesson 3, adding and subtracting, very shortly. Have a good one.